Welcome to AP Calculus, Self-Check 7.1. Let's go ahead and zoom in here and get started. So I'm actually going to zoom in even more so I can write neater. Today's date is January 24th, 1/24, 2022. That's right, it's a new video. Let's jump right in. So we know that our window is going to be between 0 and 6. This is, by the way, calculator enabled. It gives us a bunch of information, velocity, acceleration. This is typically how free response questions work. They give you a bunch of information at the beginning, which you might not use until part B or C. This first question, is the speed of the particle increasing or decreasing at time is equal to 5.5? Well, we don't know. We have to compare the velocity and the acceleration. So let's come over here to our calculator. I'm using this chemtech.net emulator because Rabbit EMU has stopped working. So if I turn it on, first of all, I'm going to come up here and I'm going to, I don't want to hit alpha. I want to go to the y equals, just y equals. Clear? Come on, y equals. There we go. Let's go ahead and type both of these in. So I'm just going to look at the velocity graph. I think that's all I'm going to need for now. If I need to come back and enter the other graph, I'll do that. So 2 sine of second log to get, no, not second log, but second ln to get e to the power of x. And that's going to be x divided by 4. And then all of that in parentheses plus 1. Parentheses was kind of important there. All right, so we have the function entered correctly. I'm in a second mode to quit out of that. And then I want to graph it. So our window is going to be between, I'm going to say here, 0 to 6. So 0, enter, 6, enter. I'm going to make it go a little bit faster. I'm going to turn the resolution to 4. I'm going to hit zoom, 0. I'll graph it nice and speedy, quick. Cool, there's our graph, cool. And we are looking at t is equal to 5.5, so I'm gonna hit trace, 5.5, hit enter, and it's talking about that spot right there. So the first thing that I'm noticing is that the height here is less than 0. It's a negative value, right? So I can come back over here to my self-check and I can say, well, my velocity at 5.5, my velocity, oh God, the lag is real, please computer, 5.5. Velocity is less than 0. I'll tell you exactly what it is. It's negative 0.453. 453. And we also need to know the acceleration there. So I could do the acceleration, but the main thing that I know is that the acceleration here is negative. There's this downward slope, right? So I'll say that the acceleration at 5.5 is negative. So I can say it's less than 0. And if you want to know what it is exactly, I can tell you. I've already pre-calculated it. It's negative 1.359. 359. Again, I can just plug into my acceleration formula, which I don't need to right now. I just know that it's negative. And because of that, we can say that, yes, they're both the same sign. So I'll come here to my text tool. I think size 12 should be fine. Let me type here. Yeah, I can say, yes, the speed is oh, it's not saying is it increasing or decreasing. So I don't want to say yes. I'll just say the speed is increasing. Why? And I'll say at time is equal to 5.5 because, or maybe I'll just write the B/C because that's a little bit faster, because V and A have the same sign. And that's as much as I need to say. Part B, find the average velocity of the particle between 0 and 6. So this is just another formula that you need to have memorized, which is this. So I'll say the average velocity, maybe I'll just say average V. Average velocity is this formula given by the integral between the two bounds, 0 to 6, of acceleration. So it's average of anything is it's not acceleration. It is the average of velocity. You do the integral of velocity and you divide that by your total time. So I'll just say 6 minus 0. That's the general definition here. If I'm asking for what is the average acceleration, then this V would change out for an A, right? Acceleration. What this letter and this letter have to match each other whenever you're talking about averages. Because essentially what this is saying is that this is the total change in position when I take the integral of velocity. The total change in position over the total change in time is the average velocity. So we need to actually calculate what this is, and luckily I have this calculator over here that can do it for me. So if I Second, quit out of this to go to this screen. I essentially want to type in this integral. So I'm going to go to math 9, and it's going to do the integral between 0 and 6. And I want to do that y1. So vars right, enter, enter, right, enter, enter. Come on, computer. And with respect to x. All right, and then I want to take all of that and divide it by 6. So I can say all of that, and then divide it by 6. And I will get 1.949. And that is the answer. So I'll say this is equal to 1. Come on, the lag. I cannot handle 1.949. 949. And then units are kind of important because it doesn't say so, but let's just be careful from here on out because we have... I'm a liar. There are no units in here. I thought it was going to say seconds or anything. There are no units. Never mind. Units are not important. Let's move on to part C. Find the total distance traveled. And that's very similar to this. This is the total displacement, total distance traveled. Whenever you hear total distance, you need to be thinking absolute value. That's what total distance really means. So in that case, it's going to be the integral. Oh God, come on computer, you got this. The integral between 0 and 6 of the absolute value of velocity. Absolute value of velocity in this case. And again, it is a free response question, so maybe we should say v of t dt to be formal about this. And I can say down here, I can change this to v of t dt. It is free response, we should be formal about it. V of t, and then and absolute value, then dt. And then just plug that into our calculator. What do we get here? So on the calculator, come here calculator, we're going to do math 9 and then 0 to 6 of, okay, now we want to do absolute value. So math, right, enter, absolute value, and then vars, right, enter to do our y1 variable. And then just all that with respect to x. And then it'll take a little bit of time. Absolute value usually is a little bit more intensive on the processor. Should get about 12.573 is equal to 12.573. Excellent. Moving on to part D. For that same interval, the particle changes direction exactly once. Find the position of the particle at that time. All right, well, that's a little bit harder, but we need to look at the graph. So if we're going to look at the graph of velocity, right? If I change velocity from a positive to a negative, that means I was going forward and then I'm going to go backwards, which means I've changed direction. And luckily we already have that graphed. And it happens right there. I was going forwards, I have positive velocity, and then all of a sudden I have negative velocity. I was going forwards and then I go backwards. I must have changed direction wherever I cross this t-axis. So how do I find that value? And then this can be second trace to do the calculation of that 0. So I'm going to hit 2. And the left bound, I don't know, I'm going to guess like 4. And my right bound, I'm just going to say 6, the very right-hand side, and I'm just going to guess 5-ish. And it says 5.1955. Again, this last 5 is going to be rounded to a 6, so 5.196. I'll say that this is 5.196.196. And my handwriting has become terrible, hasn't it? 196. That's the time that it's asking for. At what time does it change? Oh, but it's not asking for time. It's asking for position at that time. So this is the time. So we need to do a start plus change is equal to end. So we're looking for an end value. So we're going to do start plus change. Oh my gosh, my computer. I'm literally having 2 applications. Recorder, this little Chrome web applet, and then this PDF, and my computer can't keep up. Isn't that atrocious? Plus change, and that's going to equal to our end. So our start value, what is our start? Does it say up here at the beginning? It says, hey, at time is equal to 0, we start at position 2. That is all of our start information. So this is our start time and our start position. So our position starts at 2. Plus, and then we're going to do this integral from the start time, which I already said was 0, and then our time end, which we just found right now by looking at this x-intercept, or this t-intercept, if you will. This is going to be 5.196 of velocity, v of t dt. I'm being formal about it because it's a free response question now. and I just need to use the calculator. So I'm going to come over here, second, quit to get rid of all of you. Let's go ahead and clear the screen. I'm going to do our start, which is 2 plus, I'm going to do math 9 to do the integral between 0 and, it's okay if you round. I'm just going to type it 5.196. I know I always advocate that you should store your answers, but it's not going to be that far off. That's the reason we round to 3 decimal places of that VT. So that's the var's right, enter, with respect to X. Let that do its thing. It should be about 14.135. There it is, 14.135. So come back over here, 14.135. Excellent. So that's the solutions for self-check 7.1. Let's go ahead and correct everything. How many points is everything worth? I could look at the scoring guide, but let's go ahead and just jump through this really quickly. If you say that the speed is increasing, I'll give you plus 1 point. Oh gosh, it's the lag. I swear it's not me. I know my handwriting is bad, but it's not that bad. If you say it's increasing, I'll give you a point. And if you have the rationale, I'll give you another point. And that's the V and A have the same sign. Can I just do a red line because my computer is not going to be able to handle. There. You have all of that stuff. It's another plus. Come on, computer. This is ridiculous. Plus 1 point. So part A was just out of 2 points. So usually what I do off to the side, maybe off to the left here, I'll say part A, that is out of 2 points. And then what about for part B? Part B, I'll give you 1 point if you set up the formula correctly. So all of this stuff, if you have the general formula, I'll give you plus 1 point. And if you got the answer rounded correctly, of course, another plus 1 point. So part B was also out of 2 points. Come on, computer, out of 2 points. Part C, I'm going to give another 2 points. It's kind of the same thing, formula and answer. And that's typically the way these things go. And I will say that if you wrote all of this stuff correct, all of the formula, that's going to be plus 1. And if you forgot to do the DT, start doing the DT. That is included as part of that point. We need to be formal about this. And again, I'm going to give 1 point if you got the answer. So again, part C is out of 2 points. 2 points apiece, we're at 6 points. That means the last one has to be 3 points to add up to 9. So, oh my God, come on, computer. I just want to scroll down. Divided by 3, yes. This is out of 3 points. Where do those 3 points occur? Well, this is the funny one. You get 1 point if you remembered the start condition. Remember how there's always that easy plus C from the last unit? Well, this is your free point right now. Just remember that there's a start. You get another 1 point if you got this whole integral. I guess I should circle all of this integral correct, the change essentially, which means you did have to get that number correct. That's another plus 1 point. And finally, plus 1 point for the answer. And every time that you have a table like this, I guess we should have a conclusion. Let me go ahead and type my conclusion, because sometimes it's unclear. You've done a lot of math and the AP greeter has trouble. What did they say in his answer? So at time is equal to 5.196. The particle changes direction at position 14.135, that thing we just wrote down there. And I can make that all one line. Cool. Make sure that you have everything in a nice, concise conclusion for the AP grader. Excellent. That was self-check 7.1. Let's immediately move on to self-check 7.2. All right, so I haven't looked at this in a while, I'll be honest. Okay, it's a graph of velocity. There's the interval, which is super weird, but whatever. I have a feeling we're going to be needing velocity here. So let me come over here to my y equals. And it's interesting. I didn't actually need the acceleration over there because I could just look at the slope for part A. This one I'm probably going to use that sine of that x squared. Looks good. And I'm going to also change my window between 0 and square root of 5 pi. Okay, whatever. So second x squared to get the square root, and then it's going to be 5, and then pi is somewhere up here. Yes, the shift power, second power, and then in my parentheses. Okay, and that looks good. I'm going to go ahead and zoom 0 that so we can see what's. Hey, look, we get the same graph, and our graph is a little bit wonky, and that's because I sped it up. I made my resolution 4. If I make my resolution 1, it'll go a little bit slower. If I hit graph now. Yeah, it goes a lot slower, but it looks a lot smoother. It looks a lot nicer. So there it is. Cool, we got their same graph. Find the acceleration of the particle at time is equal to 3. Well, one thing that's nice to know is that the derivative of velocity is acceleration. So if I'm looking for, I'm just going to go general, not at any time, but I'm just going to say in general, if I'm looking for, I don't want to use red, I want to use blue. In general, if I'm looking for lag, it's lag, I swear, come on, computer. A sub t, or not A sub t, A of t. A of t is equal to the velocity, the derivative of velocity. So I'll say d, not dx, but d dt in this case. D dt of v of t. And that's kind of important to note on these. I think sometimes you just get a whole point for writing out the definition of acceleration. Not in this case, but sometimes you do. So it's kind of important to write. So we know how to do that. So essentially, I'm just going to be taking the derivative on the calculator. So I'm going to go ahead and second quit out of this. And it's going to be math 8. So math 8. And that's saying, okay, take the derivative with respect to x of my vars right, enter, enter, my y1 at x equals what value? Well, it tells us at time is equal to 3, so at x is equal to 3 here. And there's the answer. So how do we write that down over here? We basically want to say a sub, or not a sub, but a of 3 is equal to, I guess I'm going to kind of rewrite all of this stuff, and that's okay. D dt of v, I'll say v of t in evaluation bar at t is equal to 3. T is equal to 3. I mean, it's essentially writing what I've done on the calculator. Oh my God, it's almost exactly. These even has an evaluation bar in the silver edition. Whew, this thing is nice. And you just say, yeah, I got a number, and here's the number. Negative 5.467. 5.467. Nice and easy, just the derivative here. Find the total distance traveled. Again, whenever you think of total distance, those keywords should mean absolute value. Every single time I see that word, absolute value. So again, give yourself your general equation, and it's between t is equal to 0 to 3. Oh, that's the same as last one. Okay, so 0 to 3. It's going to be integration between 0 to 3 then of velocity, but it's absolute value. It's total distance. It's absolute value of v of t and absolute value dt. And again, this is something that you just punch in the calculator. It's making sure you know that the definition of total distance is this equation, and can you plug this equation in the calculator? And we can. It's going to be math 9 to do the integration between 0 and 3. And I'm going to do absolute value before I do my y1. So it's going to be math right, enter, math right, enter, absolute value, and then vars right, enter, enter, vars right, enter, enter is my y1, and then all of this stuff with respect to x. And I just hit enter, wait for it to do its thing. I think I get 1.702. Let's see if that works. So I'm going to say that this is equal to 1.702. And finally, the calculator caught up to me. Mr. Snell is just so fast, right? Cool. Moving on to part C. Find the position of the particle at time is equal to 3. And this is really close, right? This is just a start plus change is equal to end. End because we're looking for the end position. So this is, I'm going to write it out. It's a, come on, computer. Start plus change. Oh my God, this is so annoying. Change is equal to end. So our start, I didn't even pay attention to the question. The start is, it tells us right here, the start time is 0 and the start position is 5. So I'm going to do my start position 5. So I'm going to do start position 5 plus this integral. And again, what is our start time? Our start time I just said was 0, and our end time, it tells me right here, our end time is 3. And then it's just going to be velocity, v of t dt. I'm not going to rewrite all of it. I'm just going to rewrite it like this and just punch this in the calculator and see what we get. So let's hop on over here. We're going to do 5 plus math 9 for our integral between 0 to 3. And we're going to do vars right, enter, enter for our y1, and all that with respect to x. We know how to enter it on the calculator. And hopefully we get 5.774. Yeah. 5.774. Easy peasy. All right. And sometimes if there's a lot of work, I do like to write the conclusion. So I'm going to go ahead and do that right now, just to make sure that they know what they're looking for. The position of the is it particle? Yeah, particle at t is equal to 5 is 5.774. It seems silly to do, but man, I can't tell you how many times I've read a student paper. I'm like, where's their answer? I've written the answer twice, Mr. Sindel. Look, it's right there and right there. You can't go wrong. All right, and finally, part D. In that same interval that we set our window, the particle farthest to the right. All right, so again, the interpretation question here. Farthest to the right. This is looking for a maximum. It's looking for the biggest one. Farthest left would have been minimum. And explain your answer. Our answer is going to be explained in the format of a table because that's the easiest, most brute force way of doing this. Okay, so let's go ahead and set up our table. So there, I don't want red. I want blue. Thank you. Blue. I think that should be big enough. Yeah, sure. Right there. Why not? That looks beautiful. And so do you. All right. This is going to be start plus change. And that's going to be equal to our end value. And then we're going to compare these end values and find the biggest one. All right, so things that you must always include in your table. You must always include the boundaries. You must include 0 and the square root of 5 pi. And any possible critical value, although there are ways to eliminate them. But just list all CVs and you've got them all. Mr. Sindel, where are the CVs? Well, you see, you have a CV anywhere that you cross the x-axis and I guess it's a t-axis. There are a lot of them. There's 1, 2, 3, 4 CVs. Okay, I'm not going to write all those down. That's going to take too much time. Let's eliminate some of these. Remember the definition of an F relative maximum. This is going to help us. So I'm going to write down an F relative maximum. An F relative maximum is where F prime, oh my God, come on computer, F prime changes from a positive into a negative, aka it goes from a positive height on a graph of F prime. This is a graph of velocity, aka F prime. So we're looking at a graph of F prime. They just call it velocity. So on this graph of F prime, we must have a change of height between a positive and a negative. Well, this x-intercept right here goes from a negative to a positive. This is a F relative minimum, which we don't care about. We care about F relative maximums. So it might be that point, it might be this point, but it's not going to be this point or this point. I'm hoping I'm making sense. I'm using this definition of F relative maximum to exclude the F relative minimum. Well, yes, all CVs listed over here is a good idea. We can eliminate some of them. So I'm only going to list the F relative maximums. Save me some time. I don't know what those are. So how do I find that value? Well, that's a 0. So I'm going to do second trace to calculate the 0. I'm going to hit 2. And I'm going to say my left bound is 1. And my right bound is, 2. And then it's between 1 and 2. So I don't know, any number between 1 and 2 should work. We got the right boundaries. It's saying 1.772. So I'm going to come back over here and say 1.772. What about, okay, we can skip that one. What about this one? I'm going to come back over here. I'm going to do another second trace to calculate a 0. So I hit 2. And it's between, well, that's 2, that's 3. So it's between like 2 and 3-ish, but it's towards the right. Oh, no, it's a little bit bigger than 3. So let's say between 3 and 4. I'm going to say 2.6. That should be a little bit to the right. Yeah, 2.6 to like 3.5. 3.5. And I'm going to guess it's about 3.1. 3.1. These are a little bit closer together, so we have to, yeah, it got it though. And it's about 3.0699, so rounding that should be 3.070. 3.070. All right, we have our potential candidates. It's not just the CVs, but we restricted it even further to only the maximums, not all the CVs. All right, what is the start position? Okay, we have it from right there. It's 5. So the start position is 5, 5, 5, 5. All right, it's all of them. And then the change is always going to be the integral. My computer just cannot keep up with me. I'm too fast. It feels good. Also bad. Why doesn't it keep up with me? You're supposed to be brand new. Integral, yes, between 0 and 0 of velocity. Okay, v of t dt. Okay, well, that's silly. I'm going to cross it out in like a yellow color. That's silly. When you have the same bound, it's always going to be 0. Guess what? 5 plus 0 is 5. New facts with Mr. Sindel. Plus, this integral between our start time is always 0. This lower bound is always 0. The upper bound is always this value in the table, 1.772. 1.772. Again, v of t dt, all that stuff, plus the integral from 0 to 3.070 that time of velocity of time with respect to time, plus the integral from 0 to the square root of 5 pi of velocity of time with respect to time dt. Okay, we have the table all written out. All we need to do is manually type these into the calculator, and then we should be good. In fact, you could probably use the graph to kind of logically figure it out. But that's a lot harder to explain. So here we go. Onto the calculator. So we're going to second mode to quit out of this graph. We're going to do 5 plus math 9. Didn't I hit 9? There you go. Math 9. 0 to 1.772. 1.772 of our vars. Right. Enter. Enter with respect to x and hit enter. It will do its thing. 5.895. 5.895. All right, one of those calculator tricks that I already showed you. Second enter to get the previous entry. And all I'm going to do is come back over the 1.772, just highlight the 1 and type over it. We have 3.070. 3.070. And you don't even need to hit left or right. Just hit enter right now. Boom. 5.788. 5.788. And then finally, second enter again, and then change all of that upper bound to second x squared to get the square root of, and this is going to be 5 pi, 5, and then second power. Okay, when you have all this stuff, you want to delete it, delete, and that should all be gone. Hit enter, and we've got 5.752. 5.752. All right, we did all the hard work. Now we need to do the analysis of our table. Again, we're essentially looking, what's the biggest? Farthest to the right. Which of these numbers is the biggest? That one's the bigger number because it ends in 0.8. All these others are 0.7, 0.7, or just 5. That one wasn't even close. So we make our final conclusion. You can't just circle your answer. That's a lazy person's game. So we're going to go ahead and make our conclusion. We'll say, hopefully I'll be able to fit it in right here. We'll say farthest to the right at time is equal to 1.772 at position 5.895. And you might be asking, well, Mr. Sindel, it's only asking for the time, t. You don't have to tell me the position. Sometimes these questions ask for time, sometimes they ask for position, and I know that students get confused on which one they're supposed to get answered, even if it's like a silly mistake and you knew at the very beginning. If you always answer both of them, you'll never make a mistake. So answer both, the time and the position for both of these, or these types of questions. Just give all the information. You cannot be wrong then. They don't care that you gave extra information as long as part of it was right. And again, there's a lot of things I did, so I'm going to go ahead and box my final answer. There it is. Whew. All right, and before I end this video, how do you score this last part? We didn't go over that. Well, part number 1, you get only 1 point. So out here to the right-hand side, this was only 1 point. And you get that 1 point if you got the right answer. Plus 1 if you got the right answer. Sometimes they do give a point by saying, hey, acceleration is the derivative of velocity. So write those formulas, guys. In part B, I'm going to make this out of just 1 point again, because there's a lot of work that we did in part C and D. And again, I'm only going to give you 1 point if you got the right answer. Plus 1 if you got the right answer. Again, be writing out the formula though. It's a good habit to get into. Part C is going to be out of 3 points. And because of that, 3, 4, 5, this one must be out of 4 points. And I'm looking at my answer key. Ooh, it's out of 8? I might have to change that right here. I'm changing that from last year. Let's add a point somewhere else. But 3 points. You're going to get 1 point for getting the starting position. I'll give you 1 point if you got all of this integral, this whole integral right here. If you wrote that, give yourself 1 point, and I'll give you 1 for writing the answer. In this next one, I said 3 in my answer key, and that is about on par out of 3. So what am I going to do here? Let me go ahead and again give you 1 point if you found these 2 critical values. So those 2 are going to be plus 1. There's a better way to make this a little bit more to the right. That's plus 1 if you got those 2 critical values. I'm going to give you Plus 1 if you got the right answer, 5.895, and you selected 1.772. If you've narrowed it down, I'm going to give you plus 1. It doesn't necessarily have to have 5.895 because the question only asks for 1.772. If you kind of make this key getaway 1.772, takeaway, that's the word I'm looking for, give yourself 1 point. And then the rationale is a point. And our rationale is a table. If you have a table, give yourself plus 1 point. Our explanation is with this table, all the potential candidates. And you'll notice that doesn't have to 9. 3, 6, 7, 8. Okay, give myself another point. I'm going to go ahead and just give it for this one. This is a formula that I want you to memorize. I'm going to change this instead of 1. I know I lied. I'm sorry. Go ahead and erase. This is going to be out of 2. I can hear people whining through the computer. You're making me erase. All right. As always, let's zoom out here. Give yourself the correct number of points out of 9 for each of these. Out of 9. Out of 9. And thank you for watching.